All right, so it says compute. There's a footnote there. I'll go over the footnote in a moment. I will go to the whiteboard to do it, but I do want to point out, you're watching the video. This over here, it's all written up for you. But I do want to go over the Stanford Math Tournament. It's an annual high school mathematics competition hosted by Stanford University. The competition aims to promote interest and enthusiasm for mathematics among high school students by providing them with challenging and thought-provoking problems to solve. And this is one of the problems. All right, let's go to the whiteboard and see if we can figure this thing out. All right, the first thing to do is just write down what they're asking me to do as between 1/2 and 2. Then I get this arc tangent of x, and this is going to be x squared minus x plus 1 dx. Well, it's time to think. It looks familiar, but I'm not really sure what to do at this point. And one thing is, kind of maybe just examine the arctangent for a moment. And I'm going to say that I'm looking at this thing, and the ratios I know are between 1/2 and 2. So the invertible region I'm looking at for tangent is this thing over here. So I know my angle theta, whatever it is between 0 and pi over 2. It's an acute angle. So what I'm going to do is just draw a picture and try to visualize what they got over here. And I'm going to say theta's here, and I'm going to say this is x, and that's a 1. And the reason I'm saying that is the tangent of theta would equal x over 1, which means the angle theta would be the arctan of x. All right, that's not so bad. So the next thing I'll do is talk about this guy over here, and this would be pi over 2 minus theta. All right, let me talk about that. The tangent of pi over 2 minus theta would equal 1 over x, right? Which means pi over 2 minus theta equals arc tangent 1 over x. And then I get pi over 2 minus the arctan 1 over x would equal theta. Well, this helps me a little bit because I can actually rewrite the integral. And I'm not going to say it helps a lot, but let's put this over here. So 1/2, and then I get 2 over here. And I can write that top down now as pi over 2 minus the arctan of 1 over x. And then I get in the bottom, I get x squared, I'm sure I'm doing that right, minus x plus 1 dx. All right, so that's one thing you could do. And the question is, what do you do about that? Well, I'm going to make a substitution now. And I'm going to say let u equal 1 over x. And then du would equal, this is x to the minus 1, right? So that's going to be minus 1 x squared dx. I'm going to plug this in now, see what we end up with. Okay, so u substitution, something to do, and plan around the arc function, something to do. Let's see if this leads anywhere. So it's going to be pi over 2 minus the arctan. That's going to be u now. This will be, let's see, u is equal to this. So that means x squared would be 1 over u squared. Let me see if I did that right. Yeah, looks good. So 1 over u squared minus 1 over u plus 1. And then dx is going to be minus x squared du is equal to dx. Let's write that down. So minus x squared is going to be minus 1 over u squared du is equal to dx. I can write that down. Times minus 1 over u squared. This looks like it might be getting more complicated. That's a u. But let's play around with it a little bit. So what do you get over here? I didn't do the limit yet, did I? So I'm looking at this thing. If x is 1/2, this would be 2. And if x is 2, this would be 1/2. So I'm going to maybe rewrite this a little bit differently. I'm going to pull the minus 1 on the outside, which reverses the limits of integration now. So it's 1/2 to 2. I still get pi over 2 minus the arc tangent of u. And this is going to be du over here. Now I can just put the u squared across. What do you get? 1 minus u plus u squared. And lo and behold, it seems like it's returning back to the beginning, right? It does, doesn't it? And that's kind of remarkable, isn't it? So I'm thinking about this over here. I could just simply say let u equal x now. And what do you get there? 1/2, 2, pi over 2, minus arc tangent of x over 1 minus x plus x squared dx. All right, so I got that part covered. Let's take a look at the original integration now. Let's write that down again. See if you can use any of this information over here. We got 1/2 to the 2, and this is going to be arctangent of x, and we got this as x squared minus x plus 1 dx. That's the original problem, and we just showed it's really the same thing as this one over here. Let's write that down. 1/2 to 2, but I'm going to split it into two integrations, by the way. Pi over 2, and then you get 1 minus x plus x squared dx. Then you get minus 1/2 to 2 arctangent of x, 1 minus x plus x squared dx. I'm going to claim over here that this guy here is identical to this guy over here. So I'm going to add it to both sides. And what are you going to get? And you're going to get 2, 1/2, 2, arctangent, x squared minus x plus 1. I realize some students might say they're in different order, but they're the same. 1 minus x plus x squared, same thing as x squared minus x plus 1. Dx is equal, pull the pi over 2 out, and you get 1/2 up to 2, 1 minus x plus x squared dx. All right, what do I want to get? I want to get this. And I think I am going to do that by dividing both sides by 2 now. So we get this over here, 1/2, 2, arctangent x squared minus x plus 1 dx is now going to equal to pi over 4. I'm dividing both sides by 2. 1/2, 2, here comes my trouble. I'm going to rewrite it a little differently. And the reason I know this is related to arctangent, I just can't remember. And so it's going to be x squared minus x plus 1. And I got to work on this now. And what are you doing about that? Well, I got to do some work, don't I? And the work I have to do is, I'm going to complete the square on it. And I'll put this over here, pi over 4, 1/2, 2, 1, x squared minus x. I know what it sounds to arctangent, I just can't remember. So half of minus 1 is minus half. You square it, get a quarter. So 1/4. And I want a 1, so that's going to be 3/4 now. Haven't changed it. I'm going to keep moving through this. Pi over 4. And you get 1. Let's write this over here. It's going to be a perfect square. Some people just remember these things, and they were able to do it really quickly. There is an advantage to that, by the way. But over here, I'm going to get x minus 1/2. All right. I got to do something now about this. And what I'm going to do is factor out a 3/4 from the bottom. So you get pi over 4, 1/2, 2. You get 1 over here. I'm going to factor out 3/4 from the bottom. So this gives me 4/3. And then you get x minus 1/2 squared plus 1 dx. You may what I'm trying to do over here. I'm trying to get the integration to look like this over here, because I know the antiderivative of this one over here. I'm trying to get that. So what I'm going to do now is I'm going to pull a constant out now, and that's going to be pi over 4. And 1 over 3/4 is 4/3. 1/2 to 2. And then over here, I'm getting 1, and I need to bring this on the inside. And it's going to be 2, because 2, I'm going to square it, and then root 3. Let's put that on the inside. What are you going to get? 2 over root 3 x minus 1 over root 3 squared plus 1 dx. I'm getting really close now. I'm going to make a u substitution now. I'm going to say u is equal to 2 over root 3 x minus 1 over root 3. And what do you get here? You're going to get pi over 3. Let's do the limits of integration now. If it's 1/2, I get 0. If it's 2, I get 4 minus 1, which is 3 over root 3. And 3 over root 3 is going to be root 3. What do you get here? 1. You're going to get u squared plus 1. And I got to put du down now. What's du going to be? It's going to be 2 over root 3 dx. I'll put that down. So it's going to be root 3 over 2 du. Well, I got to pull this together now. Pull a constant out. So you can get pi. Let me see if I did that right. Oh, I made a mistake. So, no, I don't think I made a mistake. Root 3. Yeah, I did all right. So root 3. And 3 times 2 is 6. Let's see if I did that right. Pi root 3, 2 times 3 is 6. Yeah, I did okay. And there's going to be arctangent of u. Lynch integration goes from 0 to root 3. So you can get pi root 3 over 6 arctan of root 3 minus the arctan of 0. Well, root 3 for arctangent would be pi over 3. So you get pi root 3, 6. This is pi over 3. Make sure of that. Yeah, that's right. Minus 0. So what do you get over here? Pi squared root 3, 18. And we're done. Thank you.